Okay, today we're going to be doing part one of the two problems we have here. So these are just two straight up line integrals that you have to do. Parameterize it and do all that nice fun stuff. Okay, so we are doing part one today, like I said. So we're doing this one. Okay, so calculate the line integral over c of x y to the fourth ds, where c is the right half of the circle x squared plus y squared equals 16. And so again, basically, I like to start all these problems by just graph it out, okay? So we know this is a circle, the right half of a circle, x squared plus y squared equals 16. So that's just a circle with radius 4. It's the right half of it. It's not a very good circle, and we know these values go from negative pi over 2 to pi over 2, and I'm going to state that we're giving it the conventional positive orientation. And now what we have to do is we have to come up with a parameter for a circle. And the general parameter for a circle is so x would be r times cosine t or cosine theta, whatever you let your variable be. So in our case, it is 4 cosine t, 4 sine t. And now you need to specify where your values of t are going from. And for us, they go from negative pi over 2 to positive pi over 2. Okay. So now, what our ds means, I don't know if we've defined this before. So little ds means it's the magnitude of r prime of t. Not that. So we first need to find r prime of t. So let's go ahead and do that. R prime of t. So derivative of cosine t is negative sine t. And so we just multiply that by 4. Derivative of sine is cosine, so 4 cosine t. And I think you guys are seeing how this integral is going to go. Or not integral, this square root is going to turn out to be something really nice. So the magnitude of r prime of t is equal to, so if you don't remember, it's your x squared plus y squared. So in our case, I'm going to write it out all the way so we can fully see. Squared plus 4 cosine t. And that's all squared. We need our dt as well. Okay, so let's go ahead and simplify this a little bit. This square root, or squared, gets rid of the negative, so it's positive 16 sine squared t plus 16 cosine squared t dt. And one thing to note is sine squared plus cosine squared is always equal to 1. So 1, so this is equal to square root 16, which is equal to 4 dt. Okay, so now that we have that, we need to plug in our parameter for our r line integral. I'm going to rewrite it so it's easier to see. xy to the fourth and little ds. Okay, so we set our x, or our values of t go from negative pi over 2 to pi over 2, so I'm going to write it this way. And our x was 4 cosine t. Our y was 4 sine t. And that's to the fourth, and our ds is 4 dt. Okay, so the way I would like to simplify this is we have a 4 to the 4, and let's treat this as 4 to the 1, this is 4 to the 1. So we pull out all that. Here, I'm going to move this to the side. We got a little side track. Oops, not that far. Okay. So what I would do is I would make this, I would pull out a 4 to the 6, because that's still the same thing. It just becomes an easier problem to work with. So we're left with cosine t sine to the 4t and still dt. Okay. So this becomes a u sub problem. And here, I'll just go ahead and do it over here. Let u be equal to sine t. That way du is equal to cosine t dt. And when you can either go ahead and do it, plug back in u, or what I like to do when t equals negative pi over 2, what does our u equal? Okay, so in that case, u equals -1, because if you look at a unit circle, it's down negative. Okay, so when t equals positive pi over 2, you can probably guess u equals 1. Okay, so our new integral is 4 to the 6, still out in front, 1, -1 to 1. And I believe it just becomes u to the 5th, or, sorry, getting ahead of myself, u to the 4th du. Okay, so now this becomes 4 to the 6 times u to the 5th over 5, evaluated from -1 to 1. So this is just 4 to the 6 times 1 over 5. And let me do this on my calculator real quick, guys, so I can make sure I get the right answer. And we see that this is 8,000.